Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on digital communication. This video, I'm going to show you an example how a scramble in the transmitter and descramble in the receiver actually work in pair in order to recover back the original intent transmit message. So basically, this will be the key objective of this video. After that, I will discuss on the different types of scramble and also a simple mathematical representation of a scramble. So basically, all this will be the objective of this video. Guys, this is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to send me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, just a few seconds, help me press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let me explain step by step how a scrambling actually works. Okay, so on your left is actually the scramble. Okay, scramble will be at the transmitter side. On your right will be the descramble. Okay, the descramble will be at the receiver side. These are the set of data that I actually want to send over to the receiver. So after going through the scrambling, another new set of data will appear at the junction T. So this will be the set of data that will be sending over the air, over the communication medium to the receiver. So after going through the descrambling, a new set of data will be at the junction R. This R should be exactly the same as S. So basically, the objective of this video is to explain how this data at the junction S change into the junction T after going through the scrambling. These are the set of data that will be sending over the air, over the communication medium to the receiver. After that, they do a descrambling, and finally, the data that actually received at the junction R will be exactly the same as the data at the junction S. So I will explain this step by step. So next, this little square box here are shift register. They actually contain 1 bit of data. So over here, you can see that these are the set of data inside the shift register. Okay, so basically for scrambling, they don't provide any form of so-called security. Okay, so this data can be a standard. Okay, so they can be a standard. So therefore, this form of so-called number inside the shift register can be easily available. So therefore, I am the so-called intent receiver. So therefore, I have the right format. So having the right format simply means that I have the same exact number inside my shift register as compared from the scrambler and also the descrambler. You can see that the data are exactly the same. Okay, so next, these are exclusive OR. The true table of exclusive OR is actually over here. Okay, so one thing I like to highlight, okay, in order to make my example manageable, okay, so I only have 5 shift register. But imagine this, in a real so-called scrambling example, you can have 100 over shift register. Okay, basically you can have more than 100 over shift register. But like I mentioned, I just want to explain this in a manageable way. So therefore, for my case, I only has this 5 so-called shift register for me to explain. So these are the set of data that will be so-called residue inside the shift register. So now with this, I'm ready to give you an example how this scramble actually works. So the message that I want to send over is actually here. So the first message is actually 1. So 1 will be going over here. So next, over here, the number at the 5th register is actually 1. So 1 will be a bit here. The number at shift register 3 is 0. So basically 3 will be over here. So 1, 0. Okay, 1, 0. The message outcome will be 1. So this will be the outcome after this exclusive 1 and 0. The outcome will be 1. So basically this 1 will appear over here. Again, I need to do a exclusive OR 1, 1. So 1, 1. The message is actually 0. So basically this 0 will be the one that will be transmit over to the communication medium or over the air to the receiver. So let's say, okay, the receiver received this 0 without any error. So this 0 actually received. Okay, the same thing actually repeat again on the Descrambler. Okay, so the number at the fifth register is actually equals to 1. The number at the third register is equal to 0. So exclusive all 1 and 0, okay, is actually 1. So basically 1 actually appear over here. So over here you can see that this 1 and 0 exclusive all, the outcome is actually 1. So basically this will be my received message. One thing you can see over here, okay, so basically the message that I want to send over is actually bit 1. Okay, but after going through the scramble, okay, the number changed to 0. And I actually send 0 over the air rather than bit 1. I actually send the number over the air, which is bit 0. So after receive the message 0, they go through the descramble, the message actually changed to 1. So from here you can see that, okay, whatever that I want to send at the junction S will be easily repeat at the junction R over here. So this is actually my exact message that I want to send over to the receiver. But when they actually go through the scrambling, the number can be changed. As you can see from here, the number actually changed. And then after that, this actually sent over the air. And then after going through the descramble, I will be able to successfully recover back the original message. So this is the first step. Okay, I would like to do the second step for you to understand better. So after the first step, this will be the second step. Okay, so basically they will shift. Okay, what does I mean by shift? Okay, so the original data 0 will shift to the first register. The first register data will shift to the second register, as you can see from here. The second register data will shift to the third register, and this thing go on and on. So in short, early on, these are the numbers, okay, which are in pink. So after the shifting, the data actually changed in red over here. Okay, so basically they just shift the register from 1 to 2 and etc. Being the same, okay, basically on the Descrambler, they will be exactly the same. The data also will shift like what I explained early on. So basically at the shift register will be a new set of data which are all in red over here. So this data in red, they are actually at the so-called shift register now. So now my second bit of data is actually 0. 0 will be sending over to the receiver. Okay, so what happened here is basically, let's take a look. Okay, so 0 sent over here. So basically, the data at my fifth register is equal to 0 now in red. Okay, so basically, the data at shift register 3 is actually 0 also. So 0, 0, exclusive all will be equal to 0. Outcome here is 0. Okay, again, from here, you can see that this is 0, 0. Okay, the outcome is actually equal to 0. So now I will be sending over message 0 over the communication medium. So again, let's say the so-called receiver received the message 0, exactly the same. So they will do the descrambling. Okay, so the message at shift register 5 is actually 0. The message at shift register 3 is 0. So basically exclusive all 0, 0. Okay, you can see that the outcome is actually 0. And then over here, you can see that my message is 0 and exclusive all 0. Okay, the outcome is also equals to 0. So basically, this will be my intent message that I actually sent over by the transmitter. You can see that the outcome is exactly the same. From this example, you can see that, okay, the number doesn't change when I actually go through the scrambling process. The number still remain intact, which is still 0. And I actually send over my message over, okay, let's say the receiver received the message. After going through the descramble, you can see that the number will be exactly matched as what I actually want to send. Okay, so basically this is how a scrambling actually works. Okay, so basically they change the bit. Okay, after they go through the descramble, they will be able to receive the same message that I actually intend to send. Next example is basically they having the same bits. Okay, after sending over the air, after going through the descramble, nothing has been changed. The intent message will be able to receive by the receiver. So this is actually how a scrambling actually works. Okay, so let me give you another example what happened after this process. Okay, so basically the numbers that are in red, okay, they are all in red. They are the actual data that is actually at the shift register now. So again, another new set of data, which is 1, okay, will be appeared over here. Okay, so they will shift this so-called shift into the register, as you can see from here. Okay, all the data will shift. For example, this new set of data will shift into the first register. Okay, the first register data will shift to the second register. the second register will shift to the third register. Same for the descrambling. Okay, so basically this thing go on and on, okay, until all the message has been sending over to the receiver side. So basically from here you can see that whatever number that I actually want to send, okay, basically after going through the descrambling, okay, after going through the scrambling, sorry, okay, so the another new set of data will be the one that will be sending over the communication medium. So again, after going through the descrambling, I will be able to receive the exact data that actually intend for me to transmit over to the receiver. Okay, so with this, I hope you have a better understanding on scrambling. Okay, I can't go on and on, but you can visualize how this thing actually works. Okay, so guys, before I continue, okay, I'd like to urge you guys to help me by like this video. Okay, so if you have learned something from this video, help me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. There are mainly two types of scramble. The first one will be additive synchronized scramble. This is what I have described earlier on. So earlier on, you can see that I need a set of exclusive OR and also some shift register in order for them to work. Okay, the digital data inside the shift register will be a known bit sequence. Okay, so basically this is the first type of scramble, which is additive scramble. They are often used in systems like SONET, SDH, internet, and satellite communication. Over here, you can see that the transmitter and receiver, they must stay synchronized. If not, the data will be chaos. So this is actually the first type of scramble. The next type will be the multiplicative self-synchronized scramble. They use feedback from transmit scramble bits. They don't really need some form of synchronization, but they can have propagation error, okay, which means that the error can go on and on. One of the example will be B.34 modems. Okay, so these are for the types of scramble. My last slide for today's presentation will be the mathematical representation of a scrambling. Okay, so scrambling, in fact, will be described by a general polynomial. Okay, so one of the key example, okay, as you can see from here, these are a very simple example that is actually represented by the mathematical representation. Okay, so this actually define the linear feedback shift register feedback taps, okay, for this random sequence generation. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for your strong support. I hope to see you guys soon. Bye for now. Thank you so much.